Okay. Number 18 class, we're all back into this. We're going to find the product of two matrices. In order to see if it does exist, do you guys remember what we're looking for here? Good, the inner dimensions. Nice job, Wagner. Shot out there on the video. All right, so this is going to be, this is a 2 by 2, okay? And then this, remember, is this a 3 by 2 or is this a 2 by 3? Yeah, good, because it goes rows by column. So this is going to be a 2 by 3. So this is what I know. Inner dimensions the same. That means that it's going to work. Outer dimensions are going to be the dimensions of my product, okay? So that means I'm going to have a 2 by 3 as my answer. Okay, so watch how this works. I'm going to have 2 rows by 3 columns. Okay? So I need to figure out what number goes in each of these. And that's when, like, remember when we were trying to figure out this position, we said, oh, that's in the first row and the first column. So that's what we're going to multiply. Okay? So first row times the first column. So 1 times 2 is 2. And then you got 3 times 3, that's going to be 9. And so 2 plus 9, that's going to be 11. That's what goes right here. Okay? That makes sense? Now, to find out this position, we're going to go first row times second column. So that's 1 times 5, which is 5. 3 times 0, that's going to be 0. So that's just going to be 5. Okay? Then first row, last column, or the third column. 1 times negative 2 is negative 2. 3 times 4 is going to be positive 12. So that's going to end up being a 10. And then we've got the second row now, first column. Okay? So notice what's going on here. We're going like multiplying this way and then this way. So negative 4 times 2 is negative 8. 0 times 3 is 0. So that one's just going to be negative 8. Okay. Now second row, this column. So negative 4 times 5 will be negative 20. 0 times 0 is just going to be 0. So that'll be negative 20. And then this times that. Negative 4 times that, that's going to be 8. 0 times that, that's going to be plus 0. So that's going to be an 8. All right, that's my answer. You guys figure out the rest on your own time. All right? Okay. Determinant. Determinant of a matrix is kind of easy. You're just going to cross multiply. Remember this one that you shot down, so it's not going to go really far. But then this one you shot up, so it's going to go further. Okay, and then just remember to subtract. So you cross multiply. 5 times 4 is 20. And then 1 times 7, that's going to be 7. So 20 minus 7 equals 13. Okay, that's the answer for that. You guys can do this one. Finding the inverse. In order to figure out the inverse, we need to kind of set up some parameters here. So A, if the matrix looks like this, where you have A, this is B, this is C, this is D, to find the inverse of A, this is how it works. You're going to go 1 divided by the determinant of A, which we just did up here. Okay, it's kind of like that. And then you have to kind of switch around the matrix a little bit, where A and D are going to swap. Okay, so D is now up here, A is now down here, and then C you just take the opposite, and B you take the opposite. So those ones are going to stay exactly the same, but you just have to take the opposite of them. Okay, so let's try this. Ready? So first I'm going to do the determinant. So this times this, that's going to be 18, minus this times this, which is going to be 16. Okay, so my determinant is 2. So from there, I'm going to go, 1 over 2 times, and remember I'm going to switch these guys. So now 6 is up here, and 3 is down here, and then the 2 and the 8 get negatives, or opposites. Okay, so 8 is negative. So in the last step, to figure out what the inverse is, you just have to distribute that 1/2 to everything. So half of 6 is 3. Half of negative 8 is negative 4. Half of negative 2 is negative 1. Half of 3 is, well, just 3 over 2. Yeah. Because, see right here where it says half? So half, 1/2 times 6. So it's half of 6. Well, because this is multiplication. Okay, because up here in our thing, this is multiplication. You have to multiply the determinant by each of these terms. So that would be our answer. Okay? Alright, next. These ones are easy. It says find the sum. Now it has a range where it says it starts at 1, so the first term, all the way up to the 6th term. So we're going to find 1, 2, 3, 4, 5, 6 terms. And then we're going to add them all up in the end because that's what this funky looking E looks like. Now to figure out what each number is, we're using this formula. To find our first term, we substitute in a 1. So 6 minus 3 times 1. Well, 3 times 1 is 3. 6 minus 3 is just going to be 3. Okay, that's this one. Now if I put in a 2 here for my second term, 3 times 2 is 6. 6 minus 6, that's going to be 0. Okay, then if I put in a 3 here, 3 times 3 is 9. 6 minus 9 will be negative 3. Do you guys know what the common difference is here? This is arithmetic, right? So this is going down negative 3. Now, from here, I can kind of be like, man, I know what the rest is going to look like. Okay? But if I was taking a test that was worth a big chunk of my grade, I'd also double check. I'd be like, hold on, let me just make sure that this one's 6. So 3 times 6 is 18. 6 is that. That'll give me 12. Yeah, okay, good. Right? Double check. So then the last thing you're going to do is just add everything up. Okay? So this plus this, that's going to cancel. So is this. So this is just one big fat donut. Then over here, this and this, that'll be negative 15. And then we have negative 12, which will be negative 27. Okay? The only thing I would say to watch out on these ones is part D. Do you guys see how it goes from 0 up to 5? So are we going to have 5 terms, or how many terms are we going to be adding up to? 6, right? Because it's 0 counts as one of the terms. All right. Next, it says, according to the fundamental theorem of algebra, how many zeros does the following do the following polynomials have? Okay, now look, all of this thing is like, this isn't like intimidating. Look at, according to the fundamental theorem of algebra, right? It feels like you're talking to a college professor, okay? But there's a couple words that we understand here, like zeros. Yeah, zeros are solutions. We've seen that before. So how many solutions is this thing gonna, right? So it's asking how many solutions. Now, when it came to a quadratic, there was a way that we could figure out how many solutions there were by using this thing called the discriminant. Okay, if the discriminant was positive, then that means it had 2 solutions across the x-axis twice. Okay, if it was 0, then that means that it only touched once. Okay, and then if it was negative, then that means it didn't touch at all. Okay, so look, we have a total of 2 solutions. Okay, and a quadratic is in this format where it's like x squared plus x minus 2. Right, this is a quadratic. So notice that the exponent right here, the exponent kind of shows us how many possible zeros we have. So 2. So all I'm going to do is look at my highest degree. Highest degree. Highest degree. 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 Okay? All right, last one for today. All right, so it says average rate of change. Average rate of change, this, you need to know what this means. Okay? Average rate of change, there's a synonym for it, and it's basically just the slope. Okay? So to find the slope, that's easy because all we have to do is just do the rise over the run, right? That's the slope. Or if we had 2 ordered pairs, we could find the slope by going y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, right? So let's take a look at our situation here. Looks like we've got a quadratic, so it's going to be a parabola. So I don't know what it looks like, but let's just say that it looks like this, okay? We need to look at it, what it looks like at negative 2. So here's negative 2. From this point, and we'll say that this is 1, 2, 3, 4, 5 or something, okay? And then all the way, well, this needs to come out this way. That'll help us out. All right, so then at 5, which is way up here. So we want to know, basically, what is the slope of this line right here? Okay, so we could do rise over run, or we could just say, hey, what is this ordered pair, and what is this ordered pair, and use the slope formula. So I see that it tells me from negative 2 and 5, so I already know something. I know that for this one, this is going to have an x value of 5, and then this one down here is going to have an x value of negative 2. So how do we figure out what these two values are going to be? Good. We could substitute them in. We could say, hey, I'm going to take the function, evaluate it at -2. So everywhere I see an x, I'm going to be putting a -2. Okay, so -2, so we evaluate it at -2. So -2 squared is 4. This will be -6. This will be -5. It's -11. 4 will be -7. So that means that this is -7. Okay? Now in the same sense, I'm going to take the function, and to figure out what this value is, I'm going to evaluate it at 5. Come on. So if I put in a 5 right here, that means I have to put a 5 here and a 5 here. So 5 squared is 25. 5 times 3 is 15, but minus 5, that's going to make that a 10. So this is a 10 plus 25 will give me 35. Okay? Alright, now this is my y sub 2. Y sub 2 minus y sub 1, so let's write that down. So 35 minus a -7 divided by 5 minus a -2. So I see the sleepy guy, so I'm going to wake him up. 35 plus 7 is 42. 5 and 2 will give me 7. So what's 42 divided by 7? 6. So the average rate of change, or the slope, equals 6 between those two intervals from -2 to 5. Good?